Mutate is used for making new columns primarily, or for changing existing columns. And it will allow you also to make columns based on like a transformation to other columns. So you can make, you'll see some examples, but basically you'll be able to make columns based on data that you have in other columns. So the basic syntax is just that you give data as the first argument, or you pipe in the data, and then you give the new column name is equal to some operation, whatever that you want to be in that column. You can see with our little monster friends that here we add a column, but we keep our existing columns. So let's take an example with the response time column. Say we have these response times measured in milliseconds, which is standard, but say for some reason we wanted to measure them in seconds. So we know that milliseconds divided by 1,000 is seconds. So we could make a new column called RT_S, maybe, for seconds, and set it equal to whatever's in the RT column divided by 1,000. So we do this with mutate, and that will go through row by row, and it will create this new column, and it will fill it by checking what's in that row's RT column and dividing that by 1,000. So you can see it here. It always pops it up at the end, but these are the RTs just divided by 1,000. So that's the basic way that mutate works. You give it a new column name, you give it an old column and what you want to do to the old column, and it creates like an additional column. You can also do operations like in place. So say we just wanted to update the RT column by dividing every cell by 1,000. Then we could just set the new column name to the same. So we can just kind of overwrite the existing column by giving the existing column name on the left of the equals. So RT is now equal to RT divided by 1,000, and that will work in place. So you get these seconds or response times in seconds in your existing RT column. You'll see that I haven't saved either of these columns. I have just looked at the preview because I don't actually want to divide my RTs by 1,000, but you could. I mean, if you wanted to save it, you can do just like how we did before, where you assign it back on top of your existing data frame. But that doesn't make a ton of sense. Here's one that I do want to save, and that is when you look at the word column here, you can see that we have like capitals, kind of how they would be written in text. But say we don't want that really for our data set, because that's like R is going to see this there with a capital T as different from there with a lowercase t. And for this, I'm going to use this function toLower, and that will just take any text and set it to all lowercase. So here I'll take the word column and I'll mutate it by setting it equal to the lowercase, so toLower of the word column. And I'm going to save this. So you can see that that edits in place, and now the word column is only lowercase words. So that's an example of something that you can do with character columns or factors. Something else that I find useful in working with self-paced reading data, for example, is to calculate the length of the word. Often this will correlate with the response times, right? So longer words will be read more slowly. So we can easily calculate the word length and make a new column called word_length and set it equal to the number of characters, that's this nchar command, the number of characters that are in that row's word column. So this will just calculate the number of characters. Let's see, that like 4 or 3, because we have Mary saw a. So it counts the number of characters that are in this column on the current row and puts that number in the word length column. Another thing you can do with mutate is change the data type. So earlier we showed you how to change between as factor or as numeric by using the base R syntax, where you set the column to as factor and then you kind of overwrite it over the existing column using this $sign syntax. But you can actually also do this with mutate. For that, you just the same, you have the column name and you overwrite it with the factor version of the column, or yeah, whatever data type you want to make it. So here we can mutate the participant column and set it to a factor version of the participant column and condition with the factor version of a condition column. And that should update our column types. So you can see now this is a factor with 2 levels and this is a factor with 12 levels. And there's actually very little difference as far as I know, whether you use a dot or an underscore. So the underscore is technically the tidyverse way. There might be some benefits to it, but not that I could immediately name to you. So if you're wondering why this is an underscore, my answer to you is I don't know if it matters. So go ahead and use either underscore or dot as you wish. But anyway, it's more convenient because you can do multiple columns at once. Okay, and now for a specific example of working with factor columns. If you have factor columns that have labels that are not, you want to change the labels. So for example, in this SPR example, in our condition column, we have, let's take a look. We have like condition A and condition B. At some point there'll be condition B. And maybe we as researchers know what this means, but we want to give this a more informative name so that it's a little bit more clear what condition was A and what was B. So for A, we have a match between, so a colloquium that actually matches with the word that follows it, like a purring cat or a guide dog. Whereas condition B is a mismatch. So it's the opposite, like a guide cat or a purring dog. So we can recode or basically relabel these 2 groups by using recode. So here we've started by piping in the data set and we mutate the condition column. And we want to set the condition column equal to a recoded condition column. So you have to give the column name first here, where instead of condition A, we have match, and instead of condition B, we have mismatch. So notice here that this is like the old label equals the new label, which is a little bit different from kind of the syntax that tidyverse usually has, but here we have old label is equal to new label. And if you wrap these in quotes, that's also a little bit against my rule of thumb here, but that will end up working better. So go ahead and wrap them in quotes on both sides. So we can run that. And now you see like we have match and mismatch instead of condition A and condition B. Well, we should have mismatch in here somewhere. Okay, we're gonna read in yet another data set just to get a little bit more examples of different types of data sets. This is called animal survey. And this is like a long format, or like it's a participant survey where each participant is on one line. We'll deal with this later because this is not a tidy data set. It doesn't have one observation per row. It has one participant per row. So that's not ideal, but that's the way that you'll often read in sort of questionnaire and survey data. So it's pretty realistic to have it in this format. So let's take a look. We have like participant, their age, their nationality, and then we ask them some questions about like how much they like animals and how many they have, if they want to pet animals, what their education level is, and like a ranking out of 10 for how much they like cats and how much they like dogs, right? Obviously, this is very highly scientific information that everybody collects with their studies. So we have this new data set. Let's read it in, and you can take a look like I just showed you. And you can see that the education column here is represented by numbers. So 1, 2, 3, 4, representing levels of education. That's okay. That's often what you'll get from a questionnaire sort of software or something as well. But say we want to give those informative labels, then we could mutate the education column and set it equal to a recoded education column, which has elementary school instead of 1, high school instead of 2, and so on. And here we also have everything in quotes. That's just the way that this command works best. So this will work best, recoding from character to character. So just wrap them in quotations, and then we've saved this, and now our education column has appropriate labels. Now for something that I really enjoy, which is using conditional logics like if-else conditions to create new columns. Yeah, to create new columns or to update current columns. So an if-else is kind of a common programming logic where you set a condition. So if this part is true, the first part is true, then this happens, else this happens. So you set a condition, and then you set what to do if the condition is true, and then you set what to do if the condition is false. So for example, say we want to make a categorical RT column. Maybe not super recommended, but say we want to make a categorical RT column where if the response time is less than 100 milliseconds, we want that to say short, and otherwise we want it to say long. So we'll start with a mutate command. We give the new column name, which is RT_cat, so categorical. And then if the RT is less than 100, it gets filled with this short, otherwise it gets filled with this long. When we run that, then we'll have, so you can take a quick look here, we've got a couple of short RTs going on. And then the RT_cat column now has short or long based on what the value is for that row in the RT column and whether it's less than 100. And you can also do this on categorical columns, of course, too. So you can use any type of condition that would have worked for filter. So if the word is in cat or dog, then we want the position to be equal to critical, otherwise not critical. So you can use this if your experimental software doesn't let you like denote which words are critical words, then you could always give R what your critical words are, and if it finds that in the word column, it will it can mark like critical or not critical word. Yeah, so here like cat or dog being the critical word because that's when the collocation would have been recognized. And finally, what you can use, so what if you have more than two? So this if-else works really well for if you only have two options, right? Like if this is true, then do this, otherwise do this, stop. But if you have multiple conditions, then there is the option to use case when. Syntax looks a little bit different, but basically it's going to allow you to use multiple logical conditions to fill a column, or to fill a column when used with mutate. And you can see a little example here, but I'll jump right into showing you our example on our data frame, which we are using. So say we want to have like short, long, or normal. So we want to have like less than 100 is short, whereas more than 500 is long, otherwise normal. Then we can use case when. So you start with the data frame, you pipe it to mutate, you give the new column name, which is RT_cat, is equal to case when, and then you give your conditions. So condition 1 is if the RT is less than 100. You always give this little squiggle, this tilde, and then short. So if it's greater than 500, then long. And you always, or you end it with true to catch anything that doesn't catch in those other conditions. So if this one is false, but this one is false, then this one's always true because it's true. So it has to be true. So everything else that these don't catch gets the final label. So you can also just think of that as always when you use case when, you give true at the end, and that will like apply to anything that all of the previous conditions do not apply to. So if we run that, then you'll see that we have like short, normal, and long. In this animal survey, we can also use case when. So we have these ratings out of 10 for cats and dogs. And we want to know, okay, which does each participant, did they give a higher rating for cats or did they give a higher rating for dogs? So we can mutate the animal survey data and make a new column called preference, set that equal to case when. And remember, this goes like row by row. So if in this row, the cat's number is greater than the dog's number, then we want preference to read cats. If in this row, the dog's number is bigger than the cat's number, then we want this preference to read dogs. And if in any other case, so in anything that's left, we want it to read undecided. And this would trigger here if cats was equal to dogs, right? Because we don't have like an equals to anywhere here. We just have greater than, greater than. So if they're identical, then we want to give that a label too. So we'll label that undecided. And that gives us a preference column. We actually don't have anybody in here that was undecided, but if you did, then you would have that kind of covered.